So we just got a bunch of materials in that we're going to be using to build the Puma. So these are a bunch of aluminum tubes. So that's going to be the metal structure that's going to hold up all of the propulsion components, the avionics components, and make sure it's able to withstand all loads that the craft will be undertaking.
The power team just got in the bulk of our components for the Puma craft that we're working on this summer. And our nice 10 pages of a DigiKey packing list. This is the basic layout of the power system that we've been thinking about for the Puma. Starting with the lithium polymer 4-cell battery, a charge or operation switch. So in this position, the switch will connect to the charger. On the other side, it'll connect to everything on the craft. This is that switch. Then we have fuses, and there are many fuses throughout this circuit to protect different areas of components. After that, there's a voltage sensor that hooks up to the PIXHawk. As you may remember, we have the PIXHawk, which does most of the flight processing, and then the Arduino, which handles most of the sensors. And from there, we feed into 3 different rails. That all gets linked to different stuff, different valves, the microcontrollers or sensors or whatever needs that power. So one of the things we have to do with our big boxes of components is figure out how much all of them weigh so that we can get an accurate mass estimation for the craft. Right now Jason's weighing our gigantic 50 amp switch, which comes out to how much?
181 grams.
So that's a pretty big switch. It's going to be one of the heavier components that we have in the craft after the battery and some of the power converters. But we've got hundreds and hundreds of parts to go through, so this may take us a little bit.
All right, hello. We are in the learning factory, and we're just about to start some construction on our actual design. Here's the template of it, and then here are our actual bars. I'm here with Alwyn, and then we have the learning factory.
Just finished marking out 3 of the pieces, and we're gonna go cut them up on this machine over here. Say hey, Gary.
Hello. Angle bars. And this angle bar is going to connect from the vertical truss to the thruster arm. From now on, all we have to cut are the attachment pieces, and we just have to make or order fasteners.
We recently realized that we needed some way to turn off the power remotely, or turn on the power remotely to everything. And for whatever reason, that hadn't been designed into the system before. To do this, we're going to break the battery voltage line there. In this place, we're going to put a relay. So a relay is an electromagnetic switch. For the Arduino to talk to the relay, then the Arduino needs power. So in order to power the Arduino, that means that we need a second 5-volt voltage converter. Wow, that's embarrassing. Without misspelling Arduino this time. So this 5-volt converter and the Arduino will always be on. And because they will always be on, the Arduino can always listen for a wake up or a turn off signal.
Here's our lab. Gotta wear your safety glasses. Me, Creed. Right now we have just finished pretty much our setup of our replicator. This is the 2X, so it has a dual extrusion, so you can print 2 different type of filaments and 2 different colors, or maybe one's dissolvable.